Welcome back to Maths with Mrs. J. Time for another challenge. This one's an interesting one where we have a rectangle with two circles inscribed in it. The rectangle is tangential to both circles, so we know that the radii of these circles are going to meet the sides of the rectangles at right angles. And we're also told that the circles are tangential to each other. Because the tangent to both circles is going to meet these radii at right angles, we know that the radii are going to form a straight line, all right? Because we'd have a right angle here and a right angle here. Two lots of 90 degrees make a straight line, all right, 180 degrees. We're also told this additional information that the width, or I guess you could call it the height in this case of our rectangle, is 8 units. And we have a vertical line here that goes through the tangent point of these two circles. And we're told that that is of length 6. Our challenge is to find what this x is. In order to do this, I want to add in a few extra lines. And I'll show you what we're going to do here. So the first extra line I want to draw in is coming from the center of this circle to here, and coming from the center of this circle to here. I'm also going to create, I guess you could say, the height of those triangles. All right, so if we have from there, center to there, from the center to there. Just some terminology here, just for our use, because we're obviously going to be working with some unknowns. I'm going to call the half the base of this triangle little a, and I'm going to call half the base of this triangle little b. I'm going to call the height of this triangle little h, and I'm going to call the height of this triangle capital H. Now, it's fairly easy to see the way I've drawn it that our vertical height consists of a little r plus a little a plus a little b plus a big R. I'll just say that again. Our vertical height consists of this amount, this amount, this amount, and this amount. So we know that little r plus a plus b plus capital R is going to be 8. But we know that 2 A's plus 2 B's is 6. Therefore, A plus B is, of course, 3. So we can sub that in to our equation. And we know that little r plus capital R must therefore be 5. Okay, let's see if we can get an expression for our horizontal distance. Our horizontal distance across will be little r plus little h plus capital H plus capital R. And we know that that's going to be what we're trying to find. So what we are trying to find, the value of little r plus little h plus capital H plus capital R. Now, we know that that value is 5. All right, so let's see how we can use that to help us. Let's just sub that in first of all. And we know that obviously little h plus capital H is going to be, well, plus our 5 is going to be what we want. So we need an expression for that, don't we? Let's just imagine for a minute this triangle here. I'm just extending this vertical line down here and this horizontal line across. What do you notice? Well, this triangle is the same as the triangle that I'm about to draw below. We have, as our hypotenuse, we have a little r plus capital R. we have as our vertical side, we have A plus B. And as our horizontal side, we have little h plus capital H. Now we know that R plus R is 5. We know that A plus B is 3. So what's H plus H going to equal? Well, very common Pythagorean triad, H plus H is going to be 4 using Pythagoras' theorem. So let's call that bit of information 5, sub it in, and we're actually done. So if we sub that into, what we'll call that, all right, so sub 5 into our asterisk expression, we know that x is our h plus 5, and we know that h plus h is just 4. So x must be 9. Now, the interesting thing here is that you can get a lot of different looking drawings here, different sizes of circles. You can have, this circle can be very tiny way down in the corner there, and this one can be really big, for example. As long as you have that vertical length going through your tangential point between the two circles, having that length of 6 and that length being 8, this length will always be 9. Right, due to what basically happens with this triangle here. So that's quite an interesting one to think about.